First of all, I will be doing this in English. When I was in high school, I had to take French for 4 years, and it got me in more trouble with my parents than any other subject because I could never quite understand it. So this whole female and male nouns, never understood it. We're going to be talking about container security, but when I do talks, I usually like to get some interaction going with the audience. So at this point, please stand. Look how reluctant. This is not an enthusiastic crowd. Okay. Please read out any text that you see in red. Okay? Oh boy. Bad audience.
I promise to say, make a copy.
Okay. Let's try it. Everybody together this time. No, stay up. Hey. You guys got to get coordinated a little bit here, okay?
I promise to say tissue rather than cleaners. I promise to say container registries rather than Docker registries. I promise to say container images rather than Docker images.
Okay, we're starting to lose it again.
I promise to say containers rather than Docker. Sit down.
Okay. So the main point there is containers is really a Linux concept, and Docker did some unbelievably great stuff for figuring this technology, to really making the technology go mainstream. But one of the problems I have over the last several years, I started working with Docker back in 2013. Is that we sort of stagnated at this point, at least at the low level and the engine level, right? There's been lots of innovation up at Kubernetes and higher levels, but at the low level, it's sort of stagnated. So what we've began to experiment with is on new, with the emergence of the standards, we wanted to start experimenting with new ways of doing containers and sort of breaking apart what everybody thought was a container into sort of its subcomponents so we could start to invent it. But this conference is supposed to be talking about standards. So I'm going to give a ton of credit, and not just because Red Hat bought them, but CoreOS actually triggered a lot of the standardization efforts. About a year and a half ago, I started doing a talk similar to this, when CoreOS was still a separate company, and I went to, it was out of KubeCon, and I went to a talk by CoreOS, and they actually talked about all the stuff that they had done, and at that point the light went off in my head to figure out that CoreOS was really the key factor here. So the first thing what I'd like to talk about is what does it mean to run a container? And Scott covered some of this earlier, but basically as soon as I say I want to run a container, I have to identify what the hell is a container. Or what do people mean when they say they want to run a container? What they mean is they want to run this container image that sits at a container registry, like Docker IO, Quay.io, or any registry. So there has to be, identify what that is. And so when Docker first invented the idea of a container image, right, what they did is they basically created a rootfs, right, a directory that sort of looks like root. They put contents into that root directory. They tarred it up, and they created a JSON file associated with that. And again, Scott talked about some of this earlier, but basically that JSON in the tarball became a Docker image. They had layering, which is basically having more tarballs of differences between them and changes of the JSON file. But then basically that JSON file in the tarball, that becomes a container image. The problem was that Docker Inc. controlled the standard, or controlled what that thing was. And so there was a risk at that point that, I'm going to bring up a little bad history. There was this company that we used to not like called Microsoft, who was a sponsor of this, but now we like Microsoft. So years ago, Microsoft, when the bad Microsoft used to have this thing called .doc, right? And every single release, they changed .doc. They didn't have backwards compatibility. And what they would do is they would have, they would sell a new version of Microsoft Office that supported the new version of .doc. All of a sudden, everybody started sending .docs around the environment, and everybody that was trying to read them was broken, right? So what would happen is you'd have to go and buy the new version of Microsoft Office in order to be able to look at these documents. So if one company controlled the standard for containers, all of a sudden they could start to change the container image, and other people would no longer be able to use those containers, right? Or they have to buy the latest upgrade. So CoreOS had a competing project called Rocket at the time, and they wanted to basically specify a specification for what it meant to be run a container. And they came out with the AppC spec, Application Container Specification. The problem with the AppC spec is it was different than what Docker was doing. And going back, I've been in Linux for 150 years now, or at least it feels like that. Way back when, there were two standards for packaging software, shipping software, right? There was apt and RPM, or basically Debian format and RPM. And because of that, for the last 20 some odd years, people have always had to package software in two different ways. So with containers, we found a new way to package software. And 2 years into it, Rocket comes out and CoreOS comes out and they specify a standard that's different. So now what's going to happen? We're going to have to package software in two different ways. And really the whole industry at that point realized that we have to have a standard on what these container images are. And that created OCI, Open Container Initiative. The companies that did that were Red Hat, Docker, CoreOS, Microsoft, Google, IBM, and a few others that I always forget. But basically, CoreOS, by introducing the AppC spec, kicked the industry in the ass, and they got together and said, we have to have a standard for this. And that was the OCI image spec. So I'm going to take a quick segue and talk about a little product that we've had, for many, many years. Way back when we were working heavily with Docker, one of the problems with this container image in this JSON file is they can be huge, right? Some JBoss images, I think, are over a gigabyte. So if you wanted to just look at the JSON file, right, the OCI specification for an image, you had to pull, how do you get an image to your system? You do a Docker pull. And then you can do a Docker inspect. So we opened up a pull request to Docker to say, can we do a Docker inspect -- remote and just pull down the JSON file? Rather than pulling down the image and realizing, oh, I didn't really want that image, let me just delete and let me pull another huge file. And Docker at that time said no, they weren't interested because they didn't want to complicate the CLI any more than it already was. But they said it's just, all the container images are, container registries are, is basically web services with lots and lots of container images at it. So you just build your own. Build your own tool to pull down the JSON file. You don't have to pull it down. So we introduced Skopeo. So the Skopeo is basically, Skopeo in Greek means remote viewing. So the original idea with Skopeo was to build a tool that could just go out and get that JSON file and pull it down. The guy that developed Skopeo then went on and said, well, if I'm going to pull down the JSON, I might as well pull down the image bundle. And if I'm going to pull it down, I might as well learn how to push it. So he learned how to push it. And so Skopeo became a tool for moving container images around the environment. You don't have to pull the image and store it in local storage. You can copy from one container registry to another container registry. It was a really cool tool, and a lot of companies are now using it. So in your CI/CD system, if you want to copy from, say, a Docker I/O and put it into your local registry, you can use Skopeo. Don't need to be root, right? There's no reason to be root on the system. So here's some commands you can do with Skopeo. The first one's inspecting, but you can copy between different types of container storage. So it's really kind of a cool tool. I think of it like SCP or rsync, basically a tool for moving these images from one container registry to another or between container storage. You can actually copy it using Skopeo directly into a Docker daemon if you want, for example. So now that we have, so again, Red Hat was working with CoreOS again before we purchased us. I mean, we purchased them. And we were working with them, and they were still using Rocket, and they wanted to look at basically using Skopeo technology to pull container images to the host. But they didn't want to exec out the Skopeo. So they said, could you split Skopeo into two different projects? Right? And they wanted basically Skopeo to be a CLI and then have an underlying project that just moved images around. And that became GitHub Containers Image. So Containers Image is just a library, a Go library, that allows you to pull images and push images from container registries to local types of storage. So when I want to run a container, I have to identify a container. I have to be able to pull the container image from a container registry to the host. The next thing I need to do is I need to explode the container image onto the host operating system. So the way we do it, right, I talked a little bit about layers, but basically when I pull down a container's image or basically a bunch of layers, I need to be able to store that somewhere in the system. And in Linux, we use a thing called copy on write file system. If you played with container engines before, you probably played with maybe overlay. If you played on a RHEL system, you had to use a device mapper. There's a Btrfs one, there's a VFS one. Basically, these are different ways of interacting with Linux to basically give you that layered or copy on write file system. So we basically took the technology that we had built for Docker and pulled it out into a separate library so that people could start to experiment and work at a library level on containers, and that's called GitHub Container Storage. The last thing you need to do, and this was all covered in the last talk, is you need to be able to create basically what it means to run a container. Scott talked previously about this. There's information out at the image, there's information in the container engine, and there's information provided by user or Kubernetes. All that gets merged together, written into a JSON file, and then a program gets launched, and that program is called an OCI runtime. OCI runtimes go and configure the Linux kernel to run a container, at which point the Linux container becomes a process on the system. In some cases, there's other tools other than runc. Runc is the default, but Kata containers you might have heard of. Kata is being worked on to use KVM to run a container, so use KVM separation. Google's invented a thing called gvisor, gvisor-d, and what they do is they actually implemented a lot of the Linux kernel inside of a Go program, and they're running containers under that, but they're all using the OCI specification, so they understand what that JSON file is. So everything here is all I need to do to run a container. What don't I need? I don't need a big fat container daemon. Okay? The problem with running containers is if everybody has to talk to the same daemon to get anything done in the container world, we end up with becoming the least common denominator way of running containers. Think about what Docker was doing 2, 3, 4 years ago. They were getting so many pull requests in that their engineers were not able to get any work done, or any of the work that Docker wanted. They were just reviewing other people. So everybody had different ideas of how I might want to run containers. And because there was only one way to run these things, it became a roadblock. Okay, not only that, but there's other problems with everybody doing it the same way, in that we get the least common denominator of security. And I'm going to be talking about a lot of stuff that we've been able to do by breaking apart the container engines into specific tasks, and we can run them with different security goals than everybody talking to a big fat container daemon. So I work for Openshift. Okay, that's a part of Red Hat. Openshift, for those that don't know, is Red Hat's enterprise version of Kubernetes. Okay, plus. We add additional features on top of it. But really what Openshift is we're trying to productize and do, RHEL is to Linux like Openshift is to Kubernetes. That might be one way to think about it. So I work for Openshift. Openshift's my #1 customer. They come to me and say, we need these features, we do it. My #2 customer is RHEL. So RHEL wants features also for running containers outside of Openshift. So those are the two customers. But let's talk a little quickly about what Openshift needs to run a container. So when Openshift and Kubernetes needs to run a container, one thing happens here is originally Kubernetes was totally wrapped around Docker, right? If you went into the Kubernetes code, every other line was do this with the Docker engine, do this with the Docker engine, do this with the Docker engine. Well, CoreOS wanted to support Rocket. So they wanted to be able to use Rocket underneath Kubernetes. So what and CoreOS was a major contributor to Kubernetes. And what they did is they actually made a huge patch set for Kubernetes that basically said, if def Docker, do it this way, else if Rocket, do it this way. And the Kubernetes guys said, wait a minute, we can't take this on. It's way too much work. And guess what? Eventually Pivotal's going to come along and say, if def Garden, do it this way. And they didn't want to cloud the code. So what they did is they created their own standard. So Kubernetes created a standard called CRI. CRI, see if you follow along here. Container Runtime Initiative. Okay, Container Runtime Initiative. And what that is an API that Kubernetes will call out when it wants to run a container. And it will say things like Kubernetes tells CRI to run a container, needs to identify what a container is, pull it from a registry, store it into a copy on write file system, and then needs to execute an OCI runtime. Anybody see any thing happening from the previous slides, right? There's a good line up here. So my container engineers came to me and said, we can build our own engine for running OCI images using CRI, we can build a little tiny daemon, not a thin daemon, not a fat daemon, but basically a daemon just for running, and that's what CRI-O stands for, Container Runtime Initiative for running OCI images. Okay, so basically it's tied totally to Kubernetes. Cryo is OCI-based implementation of the container runtime, but bottom line is Cryo loves Kubernetes. It is a product that is tied to Kubernetes. It does nothing else but whatever Kubernetes wants. We don't support Mesosphere. We don't support Swarm. We definitely don't support Moby, and we don't support Docker. It just lives under Kubernetes. Its only purpose in the world is for Kubernetes. If you look at the history of when Kubernetes was first coming out, Kubernetes was using Docker for the container engine, but every time Docker would release a new version, Kubernetes would break because Docker was not guaranteeing backwards compatibility because they supported all these other orchestrators and all these other ways of running containers. So what we wanted to do is guarantee that Cryo will always work with Kubernetes. So let's look a little bit deeper into Cryo now. So other things we needed for in Cryo was to be able to build that specification. Turns out inside the OCI spec, there is a tool called the OCI Runtime Tools, so that they built Go libraries for building the OCI Runtime spec. Scott covered CNI. We needed a way for managing networks. How do you manage networks? And Kubernetes uses CNI, so Cryo uses CNI. And again, that was introduced by CoreOS. CoreOS introduced the idea of CNI. Finally, there's a little tiny tool that we run for monitoring containers, and that's called Conmon. So Conmon is a container monitor. And really, all its job is to watch the container on the system. When I launch a container, on a system, there's nothing sort of watching what PID1 does. When PID1 exits, it's gone. Your container is gone. In the Docker world, Docker daemon used to do it. So anybody who ever played with Docker, if you restarted the Docker daemon, all the containers would die. That's because the Docker daemon was monitoring. So we need a little tiny program, Conmon. It's written in C, and its only job is to really watch the container. If the container exits, record its exit status, and hold open the TTY so we can go back into it. So this is what Cryo's architecture looks like, real simple. Cryo and Kubernetes uses pods instead of containers, and a pod is one or more containers. So each one of these containers is called the infra container. Infra container is basically just there to hold open namespaces, hold the C groups and hold the namespaces before you launch a container into it. So most people, when they run pods underneath Kubernetes, use an infra container, and then container array here is usually the primary container. Pods have this concept of secondary or sidecar containers, and usually the sidecar container's job is to monitor what's going on. Anybody who's ever played with Istio or heard of Istio, Istio is really a sidecar container that modifies the network interface to the primary container to basically lock it down. So that's why Kubernetes has this concept of pods. I will caution you, if you don't go wild with containers, because you end up with 15 containers monitoring the primary container. This is what I fear with the security guys doing something wacky like that, and also the performance collapses. But anyways, that's basically the architecture of Cryo. So what is Cryo Status? One of the things we wanted to do with Cryo, and this slide needs to be updated, we're now up over 2,000 tests. Anytime anybody opens up a pull request to Cryo, we have to pass over 2,000 tests. We pass the entire Kubernetes test suite, the entire Openshift test suite, the whole CR test suite, and our own internal test suite. Again, the goal is to never, ever break Kubernetes. 1.0 shipped back in 2017. I hated the fact that we shipped to 1.0 because I want us to be tied to Kubernetes. So we shipped 1.9, which matches Kubernetes 1.9. Kubernetes 1.10, Cryo 1.10, 1.11 to 1.11. Anybody could tell me what version we use of Cryo with 1.12? Anybody? Buildah? American reference of a movie? Okay, 1.12, 1.13, and 1.13, right? We're stocking the living hell out of Kubernetes, right? You never have to come in and say, what version do I need to use? It's just the same version. OpenShift 4.0, no longer 4.1, which shipped today, I believe, at least that's the email I got, went out today, no longer supports Docker. Docker is gone in OpenShift 4.1. It only ships with Cryo at this point. For those that aren't following the CNCF, Red Hat has contributed Cryo to the CNCF and is now a full member, and actually this is a CNCF shirt. They gave it to me for free for giving them code. That's part of my pay. So Cryo is now all of Openshift online, but the real goal with Cryo is to make running containers in production boring. And the key thing here is running containers in production. This is not about building containers. This is not about playing with containers. When you run containers in Kubernetes, you're running things in production, right? So we have to look at that differently. So there's big security things that we wanted to put into Cryo that are different than everybody sharing the same container daemon. So what we wanted to do, first of all, is to know hard-coded capabilities. Linux capabilities are the way you break apart the power of root. Second talk this morning talked about the problems of running root inside a container. Guaranteed, everybody in this room that runs containers runs root inside of a container, even though you know it's bad. But one of the things we can do to limit the power of root is actually drop the list of capabilities. And I'm going to show you that later. So actually, Cryo runs with about half as many capabilities as Docker does by default. And that's because it's only worried about running them in production. We're not building container images, so we can eliminate some of that. We also can default to running all containers. I've been pushing this for many years now. We should be running containers in production read-only. Guess what? Kubernetes doesn't support it yet, or doesn't like it. So I'm really always trying to push. We don't want containers to be able to modify /user when they're running in production, right? You're not building containers, you're running containers. We have Kata support. The number 2 contributor to Cryo is Intel. Number 3 is SUSE. So these are the companies that are contributing. We have better user namespace in containers. I'm going to show you some features later on. So that covers Cryo, but what about OpenShift needs more? OpenShift is more than just Kubernetes. OpenShift actually wants to build container images. So OpenShift has a mechanism for building container images. Now, can anybody in the room tell me how you build a container image? Good, you can say it. Docker build, right? Here we are, 5-6 years. The only way to create a tarball in a JSON file is the Docker build command. Okay? So OpenShift has another way to do it, and they have what's called sourced image. You do a git check-in, and then basically some mechanism inside of OpenShift runs and actually poops a container image out the back. Okay? But guess what that's using? It's using the Docker socket. So the Docker socket, anybody that builds container images right now is leaking the Docker socket into containers all over the place. Right? Everybody has to use the Docker socket because the only way to build a Docker image is using Docker build. Right? The Docker socket is the most dangerous thing you can give a user access to. Giving a user access on your system to sudo without password is more secure than giving them access to the Docker socket. Bottom line. Why? When I do a sudo to root, there's a log getting written that says I did sudo to root. If I do a Docker run, there is a log inside a Docker daemon that says I did Docker run. When I'm done, I can do a Docker destroy container, and that log file, by default, gets destroyed, at which point there's no record of me ever doing a Docker run on the system. And when I do a Docker run, I can do it with privilege, mount /host, and chroot to /host, and I am full root on your system, and you have no idea who the hell I am. So we needed a way to build a container. This guy works for me, who works with my team. His name is Nalan Daibai. He's a great guy. We're at DevConf a couple of years ago, DevConf Czech Republic, and he's in charge of container storage. And I kept on saying, I need a way to build these rootfs's, basically put my content into a directory, tire it up, and create a JSON file. And he said, well, I could do that. He said, I could build something. And he actually, over the weekend, right, the conference started on Friday, and by Sunday, he actually went up and did a lightning talk showing this tool. The story is, I wanted to call it core utilities for Linux, or something like that, and it's basically just another core utilities. And we kept on going back and forth, and he said, well, what do you want to call it? And I said, I don't know, just call it Buildah. And of course, with a Boston accent, probably doesn't translate well to a French crowd, but he made fun of my Boston accent by calling it Buildah. Okay? So Bostonians change ERs into AH sound, and that's but the thing is about this tool is, if you look at this logo here, that's a Boston Terrier. That's the type of dog it is. And it's supposed to have a hard hat on, but the first time we put this out on Twitter, first response we got, why do you have a dog wearing tighty-whities on its head? So the logo has actually changed since this, but I like to mention that. So what is Buildah? By the way, there's a coloring book. I didn't bring it with me too much to bring in luggage, but basically talks about container people. But this is the logo, and I say it looks like Nowlin, so it makes fun of me. But core utilities for Linux has a simple interface. Our goal is to basically building into a container is as simple as build a from. What does that do? That uses container image, go out to a container registry, pulls to the host, stores the data on container storage, and boom, I have a container, a builder container, just basically a reference to it, similar to what Scott showed earlier. But the next thing I want to do is I want to mount the container up. So that created that mount point that he showed earlier in the presentation. At this point, we take a quick segue to Docker copy. So Docker copy has this really cool feature that I can copy content from my host into a container. Not only that, but I can copy contents from a container to the host. Pretty cool, huh? So I saw that, and I said, I need to build a tool just like that. So I built a tool called Copy. Okay, and what Copy does is it allows you to build copy content from a container to the host, and from the host into the container. Now, Copy is, I put it in the core utils package, but I thought it was really cool to build it. But I didn't stop there. I actually built a tool called DNF. Sometimes I call it Yum, sometimes I call it DNF. And what this tool can do is actually allow you to DNF install packages into the root FS by just saying install root equals the mount directory and put the content direct. But I didn't stop there. I also created a tool called make. Okay, the make tool I built so I could basically do a make destr and specify the directory I want to mount. So the bottom line is you can use any tool in Linux to copy contents into this directory and get ready to build a container image. So then it didn't stop there. We needed basically a way to specify those fields in the JSON file. So entry point or executable, environmental variables I want it set by default. So that's build a config. Then I need to commit that container to an image, to create an image on my host, container commit, the builder commit, and then I need to be able to push it to a registry. I can push that image now to any registry, and it can be run by any container runtime, because it's an OCI specification. You can run it with Docker, you can run it with Cryo, you can run it with any tool you want to run that container image, okay? Oh, pathetic. Okay. Okay, good, great. Glad you asked. So Buildah also supports Dockerfile because basically everybody in the world has gone out and built this really bad bash script called Dockerfile, and everybody needs to support it. So Buildah also supports Dockerfile, and so we have build using Dockerfile. But of course, we need engineers want to type shorter things, so we have Buildah bud. But then.
Scripting language.
I have no idea what you just asked. Try it again. Actually, good question. I didn't call it Buildah. I decided to I built a new tool, a brand new tool, and I decided to call it Bash. So basically the idea is that you can use general scripting languages to build container images, right? We don't have to all build using the same format all the time, right? You can build container images any way you want in CSI. You want to use Dockerfile, you use it. You want to use Python, use it. You want to use other libraries. So we're working on using Ansible to build containers, but basically these primitives being built into the operating system now make it easy for a sourced image to run containers, things like that. So one of the big features of Buildah, well, number one, no container daemon. This is all doing everything locally. There's no daemon. It's not talking to Cryo or anything else. It's just building locally, okay? It's running containers using runc. Just formats the spec and runs the containers. No need to leak the Docker socket. You can work on running, actually this slide is old, you can run Buildah without being root. You can build entire container images. Any container image probably at Docker.io can be built with Buildah as non-root on a system. We're working on building minimal images. Because we can eliminate the need for DNF and make and all these other tools being embedded into the container image, we can use them from the host. We can make very, very, very minimal images. I've seen some really cool things people are playing around with just because they get to do it. You do a Buildah from scratch, put a couple of files into it, tire it up, and you're done. Okay? As opposed to, Docker has multi-stage and stuff like that, which our Buildah fully supports, but to me, it's more interesting to do it with locally. So what else does Openshift need to do? It needs to be able to diagnose problems, right? It needs basically a way to play with containers, on it. So we started looking at a tool for building and playing with pods and containers, and we call the effort libpod. So we created a GitHub containers libpod, but we actually called the actual tool Podman. So you guys are getting 2 for 1 today on this talk. I'm going to give you another talk right now on replacing Docker with Podman, okay? And you guys did not say it. Okay. First thing you do is you DNF install Podman. The next thing you do is you do alias docker equals Podman. The next thing, any questions? That's got to be the quickest presentation. But I can prove that's true, or at least this guy believes it's true. Alan Moran, no idea who he is. This has happened back in May of 2018, over a year ago. I completely forgot that almost 2 months ago, I set up an alias of Docker equals Podman, and it has been a dream. Uses my slogan, no big fat demons. Down here, Joe Thompson responds to him and said, what reminded you? He said, I ran Docker help. And Podman help came up. So, Podman is a tool for managing containers and pods on a Linux system. You can do commands. And we had a CLI, right? We just basically knew exactly what our CLI was because anywhere you Google how to run containers, it says, Docker do this, Docker do that, Docker do this, Docker do that. So we're going to copy their entire CLI. So we basically took and implemented the entire CLI and then started adding additional features. So let's go and quickly look at Podman. By the way, if you go to GitHub/containers/demos, any demo that we ever do, we actually not record it, but actually build scripting that you can run it yourself. So if you want to clone this, you can actually grab and run this script. And if you find a bug, open a pull request. So the first thing we do is we do a Podman version. And we show basically that we're at 1.3.1 right now. If we do an info, Podman info, a couple interesting things here. We're running with the overlay driver from container storage, so we're using container storage for implementing it. If I scroll up a little bit on the screen, one of the things that we always had a problem with what Docker originally wanted to do is they wanted to hard code Docker CRI-O as being the only form of registries, but we wanted to allow you to support as many registries as you want for pulling your images. We also wanted to allow you to block containers. So this is all built into containers image that you can actually specify. Say you have a rule that you can only pull images from your internal registry. You can block all of the registries and only allow pulling from your registry. You can specify which ones are insecure, and then you can specify. And what the tool will do is it'll go one by one through it if you specify a short name for a container image. So the interesting thing, we talked about Buildah, and one of the interesting things with Buildah you can do is you actually can run Buildah inside of a container. So what I'm going to do right now is I'm actually created a Buildah container, and I'm actually going to build the Docker file above. So this is Podman executing Buildah and building a container image while it's locked down in the system. And hopefully with the internet here, it'll work fairly quickly. So that just built that Docker file into a container image, and I can list out the images I built using Buildah, but I'm doing this again inside of a container. So now we show that I built this from the UBI 8 minimum, which is the freely distributable version of RHEL that you can do now for container images. And then I built another layer on top of that with everything in the Docker file, and I called it my image. So that image now can be pushed to a container registry. Right? I got to do this all inside of a container. Right? No leaking the Docker socket, no opening up access to the root on the system. But what people are doing now, including Openshift, is they're actually running Buildah inside of Kubernetes for distributing underneath Cryo for running and building containers. So you could build up your entire CI/CD system to using containers, building your container images, pushing them out to registries, and then pulling them down and doing all sorts of stuff, but basically in the total workflow without having to leak the Docker socket into it. So the next thing I'm going to do, I'm doing a little cleanup now. So everything I did there, if you notice, was running sudo before the command. So this is probably the most exciting thing about Podman, that people are really starting to play with it and look at it as a really good idea of just replacing Docker, is I can run all these commands as non-root. So what I'm going to do right now is I'm actually going to pull down that image from the container registry. And what you're noticing here is we got to clean up some of these errors, but basically it went through all the registries and then found it at the rel registry, pulled it down onto the system. And at this point, I'm going to run a container on it. I just run ls on a container, and it basically showed a container running as non-root on the host. And Scott showed that earlier in his presentation. But I want to look at the containers on my home directory. Here's the images that have been pulled down. And if I run images on the root, if I run sudo images, you'll see a different list. So this shows that basically this is doing everything in my home directory. There's nothing underneath the covers. There is nobody talking to a root running daemon to pull down these stuff. This is all happening on the host, right? So you can, the number one request I always get from customers is my engineers want to be able to do Docker things on host, but I don't want to give them access to the Docker socket. So Podman allows you to do all of that normal, CLI that everybody's used to without being root. So how is that possible? I'm going to show you a command, what's going on. So this is going to explain a little bit about what we're taking advantage of is user namespace. So user namespace has been around for many years, but almost no one's used it. Actually, and Podman is probably the first major user of it up to this point. So here I am in my home directory, and I'm going to show you what my home directory looks like. Oop. That's my home directory. Anything look strange? I'm supposed to be a security guy, right? I'm supposed to be known as a security guy, and every file in my home directory is owned by root. Seems like kind of a crazy thing to do, don't you think? Well, that's because user namespace is lying to you. So if I switch out of the user namespace, and I do the exact same command, and everything's owned by Walsh. So what user namespace does is it actually mounts, it basically sets up a setting on the kernel Well, I jumped over this, but basically what happens is there's a file on your system called etc subuid. All modern Linux systems have this. RHEL 7 doesn't have it yet, but it should soon, but RHEL 8, Ubuntu, Fedora all have it. And what happens is that it's allocated more UIDs to my user. So I have Walsh being logged here as 100,000, and then the next 65,000 UIDs are allocated to my user account. If you have the latest version of Shadow, Tills, and just do a user add, you'll see this happen. When I enter the user namespace, what Podman and Buildah do is they actually map my UID, which happens to be 3267, as root inside the container for a range of 1 UIDs. And then a range starts at 100,000 and starts mapping the next 65,000 UIDs. So I am not real root, but I'm root inside of this container, and I can actually do things like this is when you do. So I'm creating a home directory in my system called test, and I'm going to create foobar, and then I'm going to change my own 1:1 -r of test. And of course, it's always the wrong case. At which point I look at the files. Then I created a foobar that's owned by bin. If I looked in catted etc password right now, you'd see that 1 is bin. And if I go in and look at on my directory, outside of the user namespace, I created a file that's owned by UID 100,000. The weird thing here is I can actually go into that directory now, And I'm not allowed to create a file I just created, okay? Because I am not in the user namespace. If I go back into the user namespace, I'm able to delete it. So basically, these are all, I have privileges in the users, but this is not special privilege on the system. I am not root on the system. So let's go a little bit deeper into the, I'm going to exit there. Now we're going to look a little deeper at what Podman can do now with user namespace. And these are all things that Docker daemon can't do at this point. So when I run Podman up there, I'm actually specifying on the command line what user namespace I want to use. In this case, I'm mapping UID 0 to 100,000, the next 5,000 UIDs. I'm running it. We have a cool feature in Podman top that actually shows you what the UIDs of the process that are running. So inside the container, it says it's running as root, but we know on the host it's actually running as 100,000. I can prove that just by running the PS command here, and it'll show the sleep is running as 100,000 down there. Now I'm going to run a second container. This time, instead of 100,000, I'm going to run it as 200,000. So I'm running a container here on it, and I'm running as 200. Oop, I jumped over. But anyways, the second container was running as 200,000. If those containers escape, one's UID 100,000, the other one's UID 200,000, can they attack each other? Sure, the same way multi-user systems always have been able to, but we rely on discretionary access control, or what you think of Unix permissions, to protect. So by using user namespace in this way, I can launch lots and lots of containers and at least have them separated by users' UIDs. So that happens that they're, even though they're root inside the container, they're not root outside. So if we go back to the earlier talk today where it said never run root in container, if we could use user namespace, we wouldn't be root inside the container, even though we're getting some of the privileges of root inside the container. Right? So these user namespace, the problem, we haven't put that into Cryo yet. Kubernetes can't support it yet. So we're working on getting Kubernetes, and all this functionality would be able to be supported inside of Cryo as well. So I'm going to try to go through this quickly. Anybody in this room ever hear a login UID? 1, 2, 3 people. It's a cool feature that's been in Linux for a long, long time. When you log into a system, your login UID gets set. No matter what you do on the system, any process you launch will always have the same login UID. So in this case, I ran my login UIDs, login UID 3267. Now I'm running sudo, so I'm becoming root. I'm executing Podman. Podman is execing bash, which is looking at the script. So I'm 3 levels away, and look at my login UID, 3267. Right? So any process I fork and exec, going through sudo, anything, is always going to be owned by UID 3667. If I do that with Docker, it comes out as being some huge number. Happens to be -1 in a 64-bit space. Okay, that means unknown. Why is that important? Auditing subsystem. I'm going to watch, with that audit command there says, I want to see anybody that modifies Etsy shadow. So here we go, and we're doing something evil in the system. I'm running podman run, mounting slash with privilege mode, mounting slash on slash host, and then I'm touching host on the system. The audit log says that Dan Walsh touched host on the system. If I do that with Docker, it will say unset touched a file in the system. This is why I say you're giving access to the Docker socket. And the reason this is happening is because Podman works differently than Docker. Docker is a client-server operation. Everybody thinks that the container is a child process of the Docker CLI. It's not. It's a child process of the Docker daemon. Okay? In Podman, they are children. In Buildah, they are children. Okay? So that's a fundamental difference in the way the containers run in the two worlds. So quickly go through some Podman top features. I'm just going to launch containers. When people launch containers inside of the PID namespace, you're running UID 1, but on the host, this is your actual UID. I'm going to show you what SE Linux labels are associated with the container. I'm going to show you whether or not seccomp is enabled. And I'm going to show you the capabilities that are enabled in the container. So again, this is all stuff you can't do with Docker. This list of capabilities is the default list that we've sort of all standardized on the capabilities that we want to run containers when we're playing with containers. Some of these I think are weird. Audit right, I have no idea why that got changed, that become the default. But what we didn't want to do is change Podman in a way that it couldn't run all the containers the same way you'd run them in Docker. Look at this one right here, creating device nodes. Why do we need that in containers? We need that in containers because sometimes people run builds which create device nodes. So I need it in containers. When I'm in production, I don't want any container able to create device nodes. Now, there is protections against that, but if I turn it off by default, I get another level of security. Here's another interesting one here, net raw. The only reason we have net raw inside of a container is so people can ping, right? We turn that off in Cryo by default, right? Net raw has allowed people to break out of certain types of virtualized networks. By being able to format, basically net raw allows you to format a packet and put it out on the IP network in any form you want. So we turn it off by default. But that's because we're running in production. When we're playing with containers, we have to leave them on. But when you're building them otherwise, you don't have to. So this is just doing some cleanup. Just going to go quickly through pods. So Podman does not only create containers, it also creates pods. And a pod, again, as we explained earlier, is basically one or more containers. So I'm creating a pod called pod test. I create a container in podcast sleep 1, sleep 2. Now I'm going to show you that there's no pods, there's no containers running on my system. And I'm going to start the container. And at this point, you're going to have to ignore the bug that's about to appear on the screen. Okay, ignore this, please. I have no idea why that's coming up, but actually it worked. So that basically started up a pod. Now if I look at containers, you'll see that now there are 2 containers running on the system. And now I'm going to actually stop the pod, and it comes up with that. Basically now shows you that there are no containers running. So basically I can start up multiple containers, shut them down, all in the same steps. That's the end of the demo, and I think I'm about to run out of time. Am I done? Okay. Anyways, I'll make the rest of this presentation available, but there's basically some stuff that we don't support. Lastly, I just want to say that in RHEL 8, there is no longer any Docker support from Red Hat. So we will not be shipping Docker any longer in RHEL 8. We will be shipping these tools. They're available. Obviously, if you want to use Docker, you have to go to Docker and get Docker CE or Docker E. But we're basically looking at replacing these tools with these other tools in RHEL 8. So that's it, and I got no time for questions, right? All right. I'll be out around if you want to ask questions.